Assalamualaikum and hi. We are from group 4. Today we're going to present our group project, and the title of our group project was the transition fossil fuel to biofuel using used cooking oil. First of all, I will introduce myself. My name is Muhammad Ika Berma'ila. My number metric was DAK22002 UTHM. First of all, our introduction is our project are aimed to change the use of fossil fuel to the biofuel by using a cooking oil. Biofuel is the one of the form of a bioenergy that is made from a vegetable oil, animal fat or recycled cooking oil for use in diesel engine. The cooking oil that we want to highlight in this study was a palm oil. The used cooking oil has a triglyceride structure that also contain a long hydrogen, and the total carbon and environmental footprint per ton of a biodiesel production was around 0.55 T of carbon dioxide and around 58.37 pt. Is about around 40% lower compared to the first generation biodiesel, and order of the magnitude lower than the third generation. Next, for the problem statement, the current scenario that we will choose, they have the two electric vehicle and burning and mining fossil fuel. For the electric vehicle, the problem was electric vehicle need a long time to fully charge electricity. The range of movement is very limited, and charging network of electric vehicle is not as wide or as fast as a gas station. For the burning and mining fossil fuel, responsible for 86% of carbon dioxide emission in the past of 10 years. It can cause for the mining fossil fuel, it can cause the natural disaster, land degradation and earthquake. So our conclusion of the problem statement, biofuel is the one of the answer and the alternative in the fuel that can be produced because it's cheap price and easy to find.
Okay, so there is few processes in this transition. The production of biodiesel from UCO, used cooking oil, begin with the collection and transportation of UCO from commercial sources such as restaurant and catering service, and domestic user via drop-off tank in public spaces. Commercial USO is then collected in drums, transported by small lorries or van, and stored in large tank at hub. While domestic UCO is collected and designated tanks and transported by grease collection trucks. Then at the facilities, UCO undergoes pre-treatment through gravity setting and centrifugation to remove impurity, water and free fatty acids, yes, FFA. Then acid catalyst esterification is then used to neutralize FFA, converting them into ester with acid sulfuric and methanol. Then the pre-treated oil proceed to alkaline trans-esterification, where it reacts with methanol and alkaline catalyst such as potassium methoxide or potassium hydroxide to produce free fatty acid methyl ester FAME, which from biodiesel and glycerol as a byproduct. The crude oil is then refined through washing, vacuum drying and vacuum distillation to remove heavy components like polymerized FAME and sulfur traces, ensuring it meets EN 14214 standard, which is European standard for diesel engine. Methanol is recovered from the processed water, distilled and reused, while clean distilled water is also stored for reuse. Byproducts like gasoline and potassium sulfate are purified and sold, while biodiesel distillation residues are used as a fuel source within the facilities. Then the final product is high quality biodiesel FAME, ready for use in the diesel engine showcasing an efficient, environmentally friendly and sustainable process.
Okay, so now for the discussion, the transition from fossil fuels to biofuels, particularly those derived from waste cooking oil, WCO. This transition represents a significant stride towards environmental sustainability with far-reaching implications for environmental protection, public health and safety. So now, let's move to the environmental benefits. One of the most significant advantages of this transition is the reduction of greenhouse gas emissions. Biodiesel produced from WCO has a lower carbon footprint than the conventional diesel, contributing to the mitigation of harmful climate change effects. This reduction in emissions translates to cleaner air and a healthier environment for both present and future generations. Furthermore, utilizing WCO for biofuel production address waste management challenges by preventing the improper disposal of used oil, which can contaminate water source and harm ecosystem. Next, the role of green technology. Green technology plays a vital role in enhancing the biofuel production process. Researchers are exploring innovative techniques and catalysts to improve the efficiency and sustainability of transesterification, the chemical process that converts WCO into biodiesel. For instance, the use of heterogeneous catalysts such as zeolites enhance separation and reusability, minimizing waste and the environmental impact of the process. And advancements in green technology also enable the development of more energy efficient pretreatment system for WCO, ensuring high biofuel quality while reducing energy consumption. Next, for the public health and safety. Beyond environmental benefits, the transition to WCO-based biofuel positively impact public health and safety. Reduced air pollution leads to improved respiratory health and lower prevalence of respiratory disease, particularly in urban areas where air quality is often compromised. Moreover, the production and use of biofuel can contribute to energy independence and reduce reliance on fossil fuels imports, enhancing energy security and mitigating the risks associated with global instability. Then I would like to conclude that the transition from fossil fuels to biofuels, especially those derived from WCO, is a critical step in environmental sustainability. This transition offers numerous benefits, including reduced greenhouse gas emissions, improved air quality, enhanced waste management, and positive implications for public health and safety. Thank you.
Hello and Assalamualaikum. My name is Akmal Rizal and I will tell you about the conclusion of our study. For conclusion, a transition from fossil fuel to biofuel based on cooking oil does represent a promising step towards alternative fuel option. Besides cutting greenhouse gas emission, the repurposing of waste help contribute towards the circular economy. Whereas there are issues with the feedstock availability and its cost, technology development and policy can solve all these problems. More large-scale use of biofuel would drastically reduce the environmental impact of energy consumption and would be a big help for a cleaner and a more sustainable future. That's all from us. Thank you.